رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي.
Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope all of you are fine and doing well. लेक्चर का स्टार्ट करते हैं आज की अच्छी बात से। सबसे पहले आप लोगों के साथ कुरान पाक की एक आयत शेयर करना चाहूँगी जिसका तर्जुमा कुछ इस तरह से है, जो गुस्से को पी जाते हैं और दूसरों के कसूर माफ़ कर देते हैं, ऐसे नेक लोग अल्लाह को बहुत पसंद हैं। सो डियर स्टूडेंट्स, हमें भी चाहिए कि जब भी हमें गुस्सा आए हम उसको जाहिर ना करें, बल्कि कोशिश करें कि अपने गुस्से पे काबू पा सकें और दूसरों के छोटे छोटे जो कसूर होते हैं उनको हम माफ़ करते जाएं। हदीस आज के लिए जो आप लोगों के साथ शेयर करना चाहूँगी, एक आदमी ने रसूल अल्लाह सल्लल्लाहु अलैहि वसल्लम की खिदमत में अर्ज़ की कि मुझे कोई ऐसी नेकी बता दें जो मुझे जन्नत में दाखिल कर दे। रसूल अल्लाह सल्लल्लाहु अलैहि वसल्लम ने फरमाया कि बस तू गुस्से पर काबू पा ले, तेरे लिए जन्नत है। तो डियर स्टूडेंट्स, आप देख सकते हैं कि गुस्से पे काबू पा लेने का कितना अजर हमें मिलने वाला है। तो हमें पूरी कोशिश करनी चाहिए कि हम अपने गुस्से पर काबू पाया करें। आई नो कि मुश्किल है, लेकिन हमें कोशिश करनी चाहिए। एक और हदीस जो कि आपके साथ मैं शेयर करना चाहूँगी, 3 दिन से ज़्यादा ताल्लुक़ तोड़ने वाला जहन्नमी है। रसूलुल्लाह सल्लल्लाहु अलैहि वसल्लम ने फरमाया कि किसी मुसलमान के लिए दुरुस्त नहीं कि वो अपने मुसलमान भाई को 3 दिन से ज़्यादा छोड़े रखे। लिहाजा जो 3 दिन से ज़्यादा छोड़े रखे फिर वो बग़ैर तौबा के इसी हाल में मर जाए तो वो जहन्नम में दाखिल होगा। तो कोशिश की जाए कि अपने किसी भी जानने वाले से नाराज़गी जो है वो कभी भी 3 दिन से ज़्यादा ना हो। ताल्लुक़ हमें किसी के साथ नहीं तोड़ना चाहिए, फिर चाहे वो दोस्ती के ताल्लुक़ हों या रिश्तेदारी के ताल्लुक़ हों। हमेशा आपस में एक दूसरे के साथ प्यार और मोहब्बत से रहना है हमें। Today is the lecture number 7 of the unit 1, that is measurement, and in the today's lecture we are going to solve the numerical questions of this chapter. Question number 1 is, a circular pizza is cut into 3 equal parts. One piece of pizza is taken out. Estimate the degree measure of the single piece of pizza and convert the measure into radians. What is the radian measure of the angle of the remaining part of the pizza? In this question, we have to consider a circular pizza which is cut into 3 equal parts. So if we cut a pizza into 3 equal parts, it will look like this. And then we have to take out the one piece of pizza and we have to measure its angle in terms of degree and in terms of the radian. And then we have to calculate the radian measure of the angle of the remaining part of the pizza. So first of all, in the circle, there are 360 degrees. And since we are cutting the circular pizza into 3 equal parts, so we will divide 360 by 3 to get the degree measure of the single piece of the pizza. So for the single piece of the pizza, the degree measure of the angle is equal to 120 degree. And now we have to convert this angle into radian. So the conversion factor from degree into radian is 360 degree is equal to 2 pi radians. So 1 degree will be equal to 2 pi by 360 radians. So now if we want to convert 120 degree into the radians, we will multiply 120 degree by 2 pi and we will divide it by 360 decrease. So that we will convert this number into the radian, and this number will come out to be 2.09 radian. So the radian measure of the single piece of the pizza is equal to 2.09 radian. And now, solving the last part of this question, we had to calculate the radian measure of the angle of the remaining part of the pizza. So since in the complete circle there are 2 pi radians, so for the remaining part of the pizza, the angle will come out to be 2 pi minus 2.09 radian, which is the angle of the single piece of the pizza. And from this, if we subtract the two terms, the radian measure of the angle of the remaining part of the pizza will come out to be 4.19 radians. So 4.19 radian will be the angle measure of the remaining part of the pizza. डियर स्टूडेंट्स, इस क्वेश्चन में सबसे पहले हमने एक सर्कुलर पिज़्ज़ा कंसिडर किया, जिसको हमने 3 से डिवाइड कर दिया क्योंकि हमने इस पिज़्ज़ा को कट किया है इनटू द 3 इक्वल पार्ट्स, और उसके बाद हमने सिंगल पीस ऑफ पिज़्ज़ा को उसमें से निकाल लिया और उसका एंगल मेजर कर लिया जो कि 120 डिग्री के इक्वल था, और उसके यूनिट कन्वर्ट करके हमने उसको रेडियन में मेजर किया जिसकी वैल्यू 2.09 रेडियन है। और रिमेनिंग पार्ट ऑफ पिज़्ज़ा के एंगल को मेजर करने के लिए टोटल एंगल में से 1 पीस ऑफ पिज़्ज़ा का एंगल जब हम सब्ट्रैक्ट करेंगे तो हमारे पास रिमेनिंग एंगल हमें मिल जाएगा। Question number 2 is, the length of a pendulum is 1.5 plus minus 0.01 meter and the acceleration due to gravity is taken into account as 9.8 plus minus 0.1 meters per second square. Calculate the time period of the pendulum with uncertainty in it. Now, dear students, we have to solve this question to find out the time period of the simple pendulum, including the uncertainty. So first of all, the formula which we are going to use to calculate the time period of the simple pendulum is given as T is equal to 2 pi square root L over G. And now, since in this question, the terms, the physical quantities are going to be divided, so we have to first calculate the percentage uncertainty in length and percentage uncertainty in the gravity. So first of all, the percentage uncertainty in length will be equal to the absolute uncertainty, which will be 0.01, and the value, the measurement of the length, which is 1.5, and multiply it with 100. So this will come out to be 0.7%. And now the percentage uncertainty in the gravity will be equal to 0.1 divided by 9.8 multiplied by 100%, and this will be equal to 1%. And now, to calculate the time period of the simple pendulum, we will simply substitute the values of the length and the gravity into the given equation. So let's substitute the values. T is equal to 2 pi square root L over G, and instead of writing L over G, we will substitute their values, while the value of the length is 1.5 and the gravity is 9.8. And to calculate the uncertainty in it, now we have to follow the two rules. First of all, there is power of the square root, which is 1 by 2, and the power is always multiplied by the percentage uncertainty. So we will multiply 1 by 2 with the uncertainties in length and in gravity. And the second rule is, whenever the physical quantities are multiplied or divided, their percentage uncertainties are always added. So we will add 0.7% into 1%. So from this, if we simplify it, then the time period will come out to be 2.5 second plus minus 0.8%. And if we convert it into the absolute uncertainty, then this term will be equal to 2.5 plus minus 0.02 seconds. So in the time period of the simple pendulum, it is equal to 2.5 seconds, while the uncertainty in it is equal to 0.02 seconds. Question number 3 is, determine the area of a rectangular sheet with length 1.50 plus minus 0.02 meter and the width 0.20 plus minus 0.01 meter, and calculate the area. For the rectangular sheet, the area is equal to the product of length into the width of the sheet. So the area will be equal to the product of the length and the width. So this term will be equal to 1.50 multiplied by width, which is 0.20, and when the values are multiplied, then their percentage uncertainties will be added. So percentage uncertainty in length plus percentage uncertainty in width. So first of all, we have to calculate the percentage uncertainty in length and percentage uncertainty in width. So percentage uncertainty in length will be equal to 0.02 divided by 1.50 multiplied by 100, which comes out to be 1%. And the percentage uncertainty in the width is equal to 0.01 divided by 0.20 into 100, and it comes out to be 5%. So the area will be equal to 1.5 into 0.20, which will be equal to 0.30 meters square, plus minus 1% plus 5%. So in total, this percentage uncertainty will be equal to plus minus 6%. And the 6% of 0.30 is equal to 0.02 meter square. So this will be the area of the rectangular sheet. Question number 4 is, calculate the answer up to appropriate number of significant digits. In this question, we have the 6 parts and we will solve one by one. Starting from part A, we have to add the 3 numbers such as 246.24, 238.278, and 98.3. So if we add these 3 numbers, we get the result as 582.818. Now, dear students, we have to follow the rule of the significant digits, and the rule which we are going to follow in this case is the rule of addition. And in the addition, we have to see the least number of decimal digits after the decimal point. And since in these 3 values there is only 1 digit after the decimal point, which is in the 98.3, so in our answer we must have to round off this number up till 1 decimal digit. So we will round off this number as 582.8, because the number 1 is less than 5, so we will just remove these 2 numbers and there will be no effect on the number 8. So dear students, जब हम digits को add कर रहे होते हैं तो addition में हमें जो rule follow करना होता है उसके according हमें उस नंबर को देखना होता है जिसमें सबसे कम डिजिट्स हों डेसिमल पॉइंट के बाद, और इन तीनों वैल्यूज में 98.3 में जस्ट 1 डिजिट था आफ्टर डेसिमल पॉइंट, जिसकी वजह से हमने अपने आंसर को भी राउंड ऑफ कर लिया अप टिल 1 number after the decimal point. Now, part B of question number 4 is we have to multiply 1.4 by 2.639, and then we have to add this answer into 117.25. Now, this is the mixed calculation. The two rules we have to follow, the multiplication rule and the addition rule. सबसे पहले हम इन दो नंबर्स को मल्टीप्लाई करेंगे और जो आंसर आएगा उसको 117.25 में ऐड कर देंगे, लेकिन जब हम मल्टीप्लाई करेंगे तो हम उसको राउंड ऑफ करके नहीं लिखेंगे, इंटरमीडिएट स्टेप्स में राउंडिंग नहीं की जाती। तो जब हम 1.4 को मल्टीप्लाई करेंगे 2.639 से, सो वी विल गेट द आंसर एज 3.6946, एंड देन if we add this number into 117.25, then we will get an answer as 120.9446. But when we want to write down this number, we have to consider the least number of decimal digits after the decimal point. And since it is only one digit and 1.4 after the decimal point, so in our answer there must be only one digit after the decimal point. यहाँ पे रूल जो हम फॉलो करेंगे वो एडिशन का होगा, लेकिन जो नंबर ऑफ लीस्ट डेसिमल प्लेसेस हमें चेक करने हैं वो हम इस क्वेश्चन में से चेक करेंगे कि सबसे कम नंबर ऑफ डेसिमल नंबर्स या डेसिमल डिजिट्स जो हैं वो किस वैल्यू में गिवन है. So we will have to round off this number as 120.9. Since 4 is less than 5, so हम उसको as it is remove कर देंगे और हमारा आंसर जो होगा 120.9 होगा. Part C is we have to subtract the two numbers which are written in the scientific notation. 2.66 cross 10 to the power 4 minus 1.03 cross 10 to the power 3. Now dear students, जब भी हमारे पास नंबर साइंटिफिक नोटेशन में गिवन होता है तो हम उसको इजीली सब्ट्रैक्ट कर सकते हैं अगर उनकी जो पावर्स हैं वो सेम हो. तो सबसे पहला स्टेप जो है वो हमें इनकी पावर को सेम करना है ताकि हम इनके साथ एसोसिएटेड जो वैल्यूज हैं उनको हम सिंपली जो है वो सब्ट्रैक्ट कर सकें. सो जो सेकेंड नंबर है 1.03 को अगर हम इसको डेसिमल पॉइंट को मूव करें टूवर्ड्स द लेफ्ट साइड, so the power of 10 will be increases by 1, which will be 10 to the power 4. So now we can easily subtract the two numbers, 2.66 minus 0.103, and take 10 to the power 4 as the common number. So now if we subtract the numbers, we get 2.56 cross 10 to the power 4. और यहाँ पे हमने दो डिजिट्स तक आंसर को लिखना है बिकॉज इन द सब्ट्रैक्शन वी हैव टू फॉलो द रूल इन विच वी हैव टू चेक द लीस्ट नंबर ऑफ डेसिमल डिजिट्स आफ्टर द डेसिमल पॉइंट. और क्योंकि 2.66 में और अगर आप इनिशियली 1.03 में भी देखो तो जस्ट हमारा आंसर जो है वो डेसिमल पॉइंट के बाद 2 डिजिट्स को जो है वो कंसिडर किया गया है. सो हमारे आंसर में भी 2 डिजिट्स होने चाहिए आफ्टर द डेसिमल पॉइंट. Now the question for part D, we have to multiply and divide these numbers which are 112 multiplied by 0.456 and 3.2 multiplied by 120. So first of all multiply these numbers and we will get 51.072 divided by 384. And if we divide the number, we get 0.133 and so on. There are many other numbers, but we have to round off this number up till 2 significant figures, because in this question, the least number of significant figures value is 3.2, in which there are only 2 significant digits. So we will write down our answer up till 2 number of significant digits. So So the answer will be 0.13. क्योंकि इस क्वेश्चन में हमारे पास जो लीस्ट नंबर ऑफ सिग्निफिकेंट फिगर्स है वो जस्ट 2 डिजिट्स तक हैं, तो जो हमारा आंसर है वो हमें 2 सिग्निफिकेंट डिजिट्स तक लिखना है इंस्टेड ऑफ 3, 4 और मोर देन दैट. Now the question number 4 part E, we have to multiply 168.99 into 9. And when we multiply these two numbers, we get an answer as 101,520.91. But now if we look at the number of significant figures, then there is only one significant figure in this number. So we must round off our answer up till one number of significant figure. So अगर हमें इस नंबर को राउंड ऑफ करना है, so हमें 5 को रिमूव करना है, और जब 5 रिमूव होगा so उससे पहले वाले नंबर में 1 ऐड हो जाएगा which will become 2, and the rest of the number will be written as 0, 0 and 0. So the answer will be approximately equal to 2000 if we write down it in terms of the appropriate number of significant digits, because in 2000 there is only one significant digit, because the ending zeros are not significant. In some cases they depend on the least count of the measuring instrument. And also we can write down this number in terms of the scientific notation, which will be 2 crossed 10 to the power 3. So again there is only one significant digit. The last part of this question is we have to add the two numbers 1023 plus 8.5489. And when we add these two numbers, we get the answer as 1031.5489. And now, since we are adding the two numbers, so we have to find out how many numbers are there after the decimal point. So in this number, there is no digit after the decimal point. There is even no decimal points in our answer. There must be no decimal point. So if we remove the 5, we round off the 5, then before 5 there is an odd number. So it will become 2. 1 will be added to the number which is before 5. So the answer will become 1032, and this will be the answer of this question. इस एडिशन पार्ट में हमें नंबर ऑफ डेसिमल डिजिट्स देखने होते हैं आफ्टर द डेसिमल पॉइंट, और क्योंकि 1023 में कोई भी डेसिमल डिजिट नहीं है, इवन इसमें डेसिमल पॉइंट भी नहीं है, तो हमारे आंसर में भी डेसिमल पॉइंट नहीं होना चाहिए, जिसकी वजह से जब हम 5 को राउंड ऑफ करेंगे और उससे पहले ऑड नंबर था, तो इस नंबर में हमें 1 को ऐड कर देना है which will become 2. So the answer will be 1032. Question number 5 is calculate the answer up to appropriate numbers of significant digits. Part A is the ratio of the mass of the proton to the ratio of the mass of electron. And the values are already given. We just have to write down the answer into the appropriate number of significant figures. So 1.67 multiplied by 10 to the power minus 27 kilogram divided by 9.1096 cross 10 to the power minus 31 kilogram. So if we divide these two numbers, we get the answer as 0.1833 cross 10 to the power 4, or it will be equals to 1.833 cross 10 to the power 3. And now we have to write down this number up till the appropriate number of significant digits, and since the small number of significant figures in this calculation is 3, so our answer must have 3 significant digits. So we will round off this number and we get 1.83 cross 10 to the power 3. And for the second, the ratio of the charge on electron to the mass of the electron. And the values are again given. The charge on an electron divided by the mass on an electron. Mass of an electron, so 1.6 cross 10 to the power minus 19 coulomb divided by 9.1096 cross 10 to the power minus 31 kilogram. And now if we divide these two numbers, we get 0.1756 cross 10 to the power 12 coulomb per kilogram. And the answer could be 1.756 cross 10 to the power 11 coulomb per kilogram. And now since again in this question the least number of significant digits are 2, so our answer must contain 2 number of significant digits. So the answer will be 1.8 cross 10 to the power 11 coulombs per kilogram. So this will be the answer for this question. Question number 6 is, we have to find the dimensions of the Planck's constant from the given formula, which is E is equals to hf, and E is the energy while F is the frequency. So the first step is to write down the dimensions of the energy and the dimension of the frequency. So the dimension of energy is equal to ml square T minus 2. And how we know the dimension of the energy? We know the dimension of the energy by its unit, by its formula. Energy units are kilogram meter square per second square, or you can also derive this dimension from the equation of the energy or from the equation of the work done, which is equal to force into the displacement, or from the kinetic energy, which is equal to half mv square. So ignoring the constant value, since the constant does not have any dimension, you can calculate, you can write down, you can derive the dimension from these formula for the energy. And the dimension of the frequency is equal to T to the power minus 1, because the frequency has the unit of hertz, while hertz is simply equal to per second. So now to calculate, to find out the dimension of the Planck's constant, we will divide the dimension of energy by the dimensions of the frequency. So this will be equal to ml square T minus 2 divided by T to the power minus 1. And the dimension for the Planck's constant will be equal to ml square T minus 1. So this will be the dimension of the Planck's constant. Then we have to find out the dimension of the gravitational constant from the given formula. F is equals to G m1 m2 over r square, where F is the force, m1 and m2 are the masses of the objects, and r is the distance between the centers of the object. So to solve this question, first of all, we will write down the formula. The formula is F is equal to G m1 m2 by r square, and the dimension for the force will be equal to mlt minus 2 kilogram meters per second square. For the mass, the dimension is m. For the radius, the dimension will be of the length. And now if we rewrite this above equation in terms of the gravitational constant, this will be equal to Fr square divided by m1 and m2. And to find out the dimensions of the gravitational constant, write down the dimensions of the rest of the physical quantities. mlt minus 2 into L square divided by the dimension of the two masses. So this will be equal to m minus 1 L to the power 3 T to the power minus 2. So the gravitational constant has the dimension of m minus 1 L3 T to the power minus 2. So with the help of the dimensions, we can be able to calculate the dimensions of the other physical quantities if the sum of the dimensions are known to us. Now the last numerical question of this unit is, show that the kinetic energy is equal to half mv squared and the potential energy is equal to mg at are dimensionally correct. In this question, we have to prove that the given equations are dimensionally correct. So first of all, solving for the part A, which is kinetic energy is equal to half mv squared. Since we know that the energy has the dimension of ml square t minus 2, either the energy is kinetic or potential, it is potential. So for both, the energies dimensions are similar. And now if we calculate the dimension for the right hand side, so for the right hand side, there is no dimension for the constant. For the mass, the dimension will be m, and for the velocity, the dimension will be lt minus 1 to the power 2, since the velocity is squared. So this will be equals to ml square t minus 2, and it is equal to the dimension on the left hand side. So the first formula of the kinetic energy is correct. Now if we calculate for the second formula, which is the formula for the potential energy, then on the right hand side there is mgh. The dimension for mass is m. For gravity, it is lt minus 2. And for the height, the dimension will be the dimension of the length. So the dimension on the right hand side will be again equal to ml square t minus 2, which is equal to the dimensions present on the left hand side. So yes, both the formulas of the kinetic energy and the potential energy are dimensionally correct. This is the end of today's lecture. Thank you so much. I hope all of you have enjoyed today's lecture. For any kind of queries, you can write your question in the comment section. See you in the next video with a new topic. Till then, take care and Allah Hafiz.